All right, very good. Well, thanks a lot to everybody who has logged on so far. I'm sure we'll get a few more people. I'm just going to run through some preliminaries to get us started. A couple of housekeeping items for starters. Okay, so first of all, if you're just joining us, this meeting is being recorded, and we'll have the recording online within a couple of days of the meeting. In the unlikely event that this is your first Zoom meeting, a quick introduction: you're muted automatically when you start. So you can use the mute button down in the corner to unmute yourself later on when we do questions and answers. So we got the mute, unmute button. You can also start and stop your video if you want to either be seen or not be seen. You can see who else is on the call using the list of participants, and you can open the chat window throughout the meeting. You can be adding your comments or questions into the chat window, and then at the question and answer period, we will go through all those. And again, please, at the question and answer period, use the raise hand reaction down in this part of the screen to get in line to ask a question. That will automatically create a question and answer queue. Okay. Oh yeah, and this little circle is just for the chat window. All right, I want to start out by introducing the project team. First of all, my name is Aaron McKeon. I'm the project manager. I'm with the Central New York Regional Planning and Development Board. But I also want to introduce Madison County's Department of Planning and Workforce Development, led by Scott Ingmeyer. Madison County actually applied for the grant from the Department of State that's funding this project. So we're very, very grateful to them for their involvement. Lauren Darcy, Senior Environmental Planner, is also with us tonight from the Regional Planning and Development Board. From the Department of State, Kate Black is our liaison to the Department of State, helping us keep the project on track. They're providing the funding for this. And Karen Hansen from the Department of Environmental Conservation's Division of Water is making sure that as we go along, we're sticking to DEC's guidelines for this kind of project. DEC is ultimately going to be reviewing and approving this plan, so we're very grateful to have Karen's input as we go along here. As we'll discuss, one of the things that makes the 9-element planning process distinct and different from other watershed plans is that it depends heavily on digital models of the lake and watershed. So the modeling team is critical to the whole operation, and we're very lucky to have some top-notch digital modeling talent in our region. From Cornell University, we've got Todd Walter. He's running the watershed model, which we'll talk about. And Dave Matthews from the Upstate Freshwater Institute is running the digital model of Oneida Lake itself. Between the two of them, Dave and Todd have mountains of experience to draw on. So we're very lucky to have them involved. And we're also extremely fortunate to have the Cornell Biological Field Station and access to their more than 60 years of data and information and experience with Oneida Lake. Cornell University Biological Field Station is a very unusual resource. So it's just terrific to have their involvement. Lars Rudston is the director, Kristen Holek, research support specialist. They've both been extremely helpful so far in this project, and we're going to hear from Lars in just a couple of minutes. He's going to provide an update on the sort of the state of the lake. We also have a very large watershed advisory committee on this project, made up of representatives of 26 organizations and agencies that are active in the watershed. These organizations and agencies, they all have their own kind of specialty, and they bring a lot of different values and ideas to the process. Some are involved in natural resource preservation. Some are more on the economic development side. Some of these guys are doing more like research and monitoring. But it's great to have a broad base of support and interest to draw on. And critically, as I go through this, I'm going to be talking about, we're setting goals and targets, or we're developing future scenarios. Really, what I'm referring to is this group, the Watershed Advisory Committee. We're looking for consensus, essentially, on a direction as this plan, evolves over time. All right, so why are we here tonight? I'm going to just sketch out a little agenda. It's actually pretty full. We've got a lot to talk about. I'm going to provide an overview of the 9-element plan. So this is sort of a special, it's sort of special. It's not exactly the same as like a general watershed plan. It's got its own kind of character to it. So I'm going to go through that framework. Then, as I said, Lars is going to talk about the status of Oneida Lake. What, how's the lake doing? What's kind of the outlook for the future as far as we can forecast it? I already alluded a little bit to the modeling, and I'm going to explain that in a little bit more detail. We have a watershed model, and we have a model of the lake itself. Then we'll take your questions and comments. And then I hope you'll stick around for a little exercise at the tail end, just to talk about the vision for the lake and the watershed, goals, the kind of things you'd like to make sure are incorporated into this planning process. We want to get your input on those things. All right, before we do any of that, I want to make sure we're all on the same page on what exactly a watershed is. We're going to be using this term throughout the whole presentation and throughout this whole process. So, it can be a little bit nebulous if you just start using the term and you don't explain what it is. It's basically all the land that drains to a common body of water, like a stream, a lake, a bay, the ocean, Lake Ontario. We all live in a watershed. There's really nothing special about saying you live in whatever watershed. It's completely based on topography. So the elevations and landforms, the hills, valleys, and mountains around a body of water determine where a drop of rain, any given drop of rain, ends up. So whatever water that doesn't soak into the ground comes runoff and carries soil or pollutants, other materials from the land into rivers, lakes, and bays. Critically, that means that whatever happens upstream in the tributaries can show up in the receiving water. Pollutants can make their way into the groundwater. Pollutants can make their way into the surface water. So the things that are going on in the watershed affect the receiving body of water. That's the basic concept of the watershed and of the watershed plan. So what do we mean by a watershed plan? Well, it's important to distinguish between sort of lake management, if we're talking about, say boating regulations or water level management, or fishing regulations. That's all very specific to the body of water itself. Really, that's not what we're talking about. We're talking about the land all around the lake, the much larger watershed, what's happening across the region. So how does all of that, land use and land cover across that large region that feeds the lake, how does that affect the water quality in the lake itself? So, that, as you can imagine, brings in other issues, economic, social, natural processes, and they all come together in the watershed and they help determine the water quality of the receiving water. Importantly, we're not starting from scratch with this process. So back in 2004, my office, I wasn't really involved, the Central New York Regional Planning and Development Board, other staff were involved, Ann Saltman and Kathy Bertucci put together the Oneida Lake Management Strategy, which has a bunch of recommendations for the lake, sort of the first time to bring all that together. That's available online if you want to take a look at it. It's fantastic. And that's going to be helping us out as we go through this process. So just to kind of give you an overview of the Oneida Lake watershed, one of the reasons we need a watershed-specific planning process is that no single government entity really has control over the watershed. There's really not an Oneida Lake watershed entity that controls or monitors land use across the whole watershed. It's split up between 6 different counties, 69 municipalities. It's 1,300 plus square miles, and it takes in, an area that has about 250,000 people in it. So there's all kinds of things going on here. There's forests, there's agriculture, there's cities, and there's villages. Oneida Lake is taking the runoff, sediment, and pollution from a very large area. And on top of that, Oneida Lake itself is part of the New York State Barge Canal System. So it's connected to the rest of the state, the Great Lakes. I think it's good to recognize Oneida Lake is not in like a crisis mode. But as Lars is going to explain, it's a system that's always changing. And we want to get out ahead of anticipated problems to the greatest extent possible. So that's kind of the, in simple terms, that's kind of the goal of this process. All right, so we're talking about a 9-element plan. This is sort of an exotic term. In the past, as I just said, we did a watershed management plan. This is now not really this is its own creature. It's called the 9-element plan. So I do want to run through what that means. What are the 9 elements? So from left to right, the first 3 really are quantifying inputs and sources of pollution. One example is phosphorus. Phosphorus runs off of the entire landscape and it can contribute to harmful algal blooms and kind of the growth of algae. But we've got that pollutant, other pollutants. Where are they coming from? How much is in the lake? Next is trying to figure out what a good future goal is. What's a good level? What's an acceptable level for those pollutants in the lake? And then how are we going to get there? What suite of solutions are we going to look at to reduce those pollutants across the watershed? So those solutions are known collectively as best management practices. That's kind of just the industry shorthand, if you will, for the tools that you use to prevent pollutants from getting into the water body. The best management practices. So the whole objective of kind of the first phase, kind of in my mind, the more time and labor intensive phase of the project is figuring out, what pollutants are we looking at? What's a reasonable goal? And then what kind of best management practices are going to be most effective in getting to that goal. From there, you've got a separate challenge, which is the implementation plan. So what's a good timeline for implementing those best management practices? Where are you going to get the money? What are they going to cost? And how are you going to measure your progress? What's a good measure of, are we making progress toward the goal? Then these two, monitoring and evaluation, number 7 and number 8, are more kind of long term. That's like the feedback loop. In 5 years, in 10 years, we're going to look back and we're going to check the lake and say, did all of this work? Did our first 3 things come up with the right solutions? Did we implement things? And how is the water quality doing? So those are kind of they're the nuts and bolts of the process. And then the 9th element here is the stakeholder input. And I think it's important to recognize, as we said earlier, DEC is involved with this process, but this is not a DEC-led process. This is a stakeholder-driven plan. So as I said, the Watershed Advisory Committee, that's a large group of stakeholders. And of course, we have this meeting here tonight. And as we'll discuss, we're going to have a couple more of these. The idea is for the first 3, these key decisions to be made by the stakeholders and the rest of the decisions as well. So the stakeholder input is really critical to the process. All right, so all that aside, why would we use this 9-element strategy? We could just use a sort of a more normal watershed strategy. Well, the 9-element process is beneficial because it's flexible. We can do the things that you would do with a watershed plan. It is community driven. It's comprehensive, and it can address the issues that stakeholders are concerned about. Typical things: invasive species, climate change, recreation, fishery issues. These don't get left out of the process, but we do have the requirement to look at the lake scientifically and quantitatively. So at the end of the process, we'll have a numerical target for what we want the water quality to be like and a set of steps to take to reach that target. So it's got both things. It's got the qualitative and the quantitative components. So it's a very useful, beneficial process that brings a lot to the table. Oh, and critically, that expands project funding opportunities. That's not to be downplayed at all. Once you have an improved 9-element plan, you can go after larger pools of funds to enable that implementation plan to get your projects going, to make sure you hit your goals. All right, so what's kind of the timeline here? Like a lot of plot planning tasks, this one is going to take some time. Tonight's meeting is really the first big step toward project completion. We don't really have any of the 9 elements nailed down, so we got a long way to go. The goal is to come back to you in the fall with another public meeting where we're going to talk about the pollutants and where they're coming from and ways to reduce them. That's the suite of best management practices. And then the third public meeting will have a draft plan, theoretically, and that would be a year plus a couple of months, something like that. So that's the timeline roughly we're hoping for. So that's that in a nutshell, very briefly, in about 15 minutes, is the 9-element framework. So right now, Lars is going to tell you a little bit about the lake, and then I'm going to come back and we're going to run through the information about the modeling. So, all right, Lars, you are up and you can unmute yourself.
Okay, thank you. And I'm so glad to be here to talk to all of you. Aaron gave me 10 minutes to talk about the status of the Oneida Lake and what we think is happening and what might happen into the future. So just a little bit of background. We have a field station on Oneida Lake. Take the next slide. It's part of the Department of Natural Resources and the Environment of Cornell University. There's about 400 acres of land. I think click once. Nothing else comes up. Okay, so that's some of the buildings at the station. We have a lab, we have housing, we have boat houses, and we have boats. And we go out on this lake almost every week. Not in the winter time, it's a little less often, about once a month, but during this open water season, we're out once a week to try and keep track of the lake and understand its ecology and its fisheries. Take the next one. So we've been there since 1956. On the bottom, you see the happy group of students and dedicated staff that worked on the station and Oneida Lake in 2022. Every year we have this number of young, excited people there doing work. And we have been there for 66 years. There's only been 3 directors during that time, really. Ed Mills is on the call, I see. John Forney started, then it's Ed Mills, and now it's me. So I've been the director since 2009 when Ed retired. You can see that the directors get a little younger, perhaps, but they certainly get fatter as they get closer to my time. All right, next slide. So Oneida Lake is the biggest lake totally within New York State. So 200 square kilometers. I should have made this in acres, and that's about 40,000 acres. I'm from Sweden originally, so I have a hard time with these American units. It's a shallow lake. So its average depth is only about 18 feet, which means that it mixes all the time. Now, we call it a polymictic lake. That is a lake that doesn't stratify and get cold water on the bottom and warm water on top. And it's a eutrophic lake to mesotrophic lake, which means it's a productive lake. Nutrient levels are pretty high. Take the next slide. There is a lot of fish in the lake. The fishing is excellent in the lake. It's one of the most fished lakes in New York State. In fact, it's the number 2 and number 3 as far as fishing pressure of all the lakes in New York. And the ones that are high have more fishing per unit per year is large lakes like Lake Ontario and Lake Erie. Recently, we've had increases in walleyes, which is the main fish that people fish for. That has followed the first red arrow there is when cormorants were starting to be controlled, and we have an increase in walleyes. And the second red arrow is when round goby came into the lake and the mayfly came into the lake. And we seem to have seen a further increase in walleye as a consequence of that. Take the next slide. But we have a changing lake. The stage is changing. We have climate affected temperature increases in the summer. That's the red line coming up over there. Now, this is about 2 degrees Celsius in 3 decades, or 0.8 degrees Fahrenheit per decade, which is pretty fast. It's actually faster than most lakes around the world as far as increases in summer temperature. And at the same time, winter ice is declining. So right now, for example, the lake has open areas. It's not frozen. So we are getting towards one of the lowest ice duration years that we have had. We've had a few that is down to 20 degrees, 20 days, and even no complete ice cover in 2001, 2002. But overall, ice duration is declining, about a week per decade. Next slide. So one of the effect of increases in temperature in the summertime is affecting the fish population that is there, and also the algae and zooplankton. But I'm talking more here about the ice because it's wintertime, right? And we can see it right outside our windows. These are 15 lakes with over 100 years of data, and it includes 2 of the lakes from New York State, the nearby Casanova Lake and Otsego Lake. And Oneida has similar time patterns. And if you look at the lines after year 2000, it's starting to increases. The loss of ice is accelerating. On the top, the ice on date is getting later and later in the season, and the ice off date on the bottom is getting earlier and earlier. So what is one of the potential effects of this? Let's take the next slide. Is that we'll see changes in the fish populations. We have alewife in many of the lakes around New York State, and they have a large effect on young walleye. They are very good predators on very small walleyes. On that graph to the left, you see the number of young walleye produced after alewife came into Canada Rego Lake a little bit further away. After 2005, when we got alewife, we had almost no walleye fry surviving. So I'm a little worried about this. I think that alewife coming into the lake will have a strong effect on both zooplankton and on walleye populations in the lake. We'll see what happens. And of course, ice fishing is going to decline. Next slide. So that's the stage changing. We also have players changing. Next. And these are invasive species that are coming into the lake. And I'm going to talk just briefly about these 4 species. And we have the mussels, the zebra mussels up to the left, the quagga mussels down to the left on the bottom. Then we have the spiny water flea, which is that strange looking creature with the long spine, and the round goby over to the right side. Okay, next slide. We know mussels have large effects. So this is chlorophyll levels over the season. And chlorophyll is the measure of the algae we have in the lake. This is how, on average, a season looked like before mussels came into the lake. Next one. After zebra mussels came in, there is less chlorophyll most of the time. Throughout May, June, July, August, September, less chlorophyll, clearer water. We have seen that. Next slide. And when quagga mussels came in, we still have the clear water, less chlorophyll in the summer from June to August, but we also see it in September, October, and in March and April. And this is because quagga mussels, in contrast to zebra mussels, are active at cold temperatures. So these mussels are the most abundant animal in the lake now, most biomass, and it's a strong filter feeder and causes these effects on the lake. So clear water, less chlorophyll. All right, next slide. So what happens when round goby comes in? Now we got the first round goby in 2013, and by 2014 they were spread across the lake, and by 2015 it was quite abundant. We go diving every year to look for where the mussels are, and this is a picture of where the gobies, yeah, you can do that.
Yeah, okay.
Gobies under the water on the bottom. The rings shows where there were gobies in that particular picture. If I had more time, I usually ask people how many they see, and they see 1 or 2, but there are actually 9 of them on that particular picture. So we're trying to keep track of them as well. And what can we expect to happen when a species comes in and goes from a very few number of fish to about 200 million fish in 3 years? It's quite dramatic, but it's a big lake, right? So let's take the next slide. One thing that they're doing is they feed on mussels. So we've seen a decline in many of the invertebrates that are on the bottom, including the snails, including the little scuds, but also in the mussels. And you can see those yellow bars here is the density of quagga mussels in particular going down over time. Gobies is the black line, and they have increased at that point, that time. So they are moving energy that has accumulated in mussels up to fish, because walleyes loves to eat these animals. So does bass. But they're changing the lake. We have this constant new species coming in, changing how the lakes behave. Next slide. We have two more big changes going on right now. In 2019, the first time we found this little spiny water flea, which is on the bottom. It has a big spine. We think it might affect how young fish can eat on zooplankton, and they do decrease the zooplankton that young fish typically likes to eat, which is called Daphnia. It's not more than a few millimeters long, so about 5 millimeters perhaps, but it does have a large effect. It's a predator on zooplankton, and this is one of the main studies we're working on right now. Whether it's going to be negative or not, I'm going to wait and tell you in the fall. Perhaps not so bad as we expect. And then the next slide is the return of the eel fly or the burrowing mayflies. So if you live around Oneida Lake, you probably have seen this large amount of exuvia, so the bodies of these mayflies along the shore. This summer, there was actually enough of them dying and lying along the shore that it started to smell a bit. But these animals spend about 2 years in the bottom feeding on sedimented material, and then they spend about a week up as adults. They mate and they lay their eggs, and then they die. So we are getting up to numbers that we had in the 50s and early 60s in Oneida Lake, which has a large effect on the population and on the food web of the lake, because fish like walleye and yellow perch eats these things, and they eat them at the time when they otherwise would have eaten larval fish. So the dynamics of getting these animals back is fascinating to us. All right, next slide. So here's some of the predictions. I hadn't had time to talk about all of them, but the water will get warmer. This temperature stratification is probably going to increase and the ice duration decline. Because stratification increases, we do expect internal nutrient loading to increase. And this is one of the things we want to use these models to explore. I'm really excited about having the in-lake models working on predicting the stratification and predicting phosphorus release from the sediments. I predict also that airwack will become abundant and that the fish community will shift in the next several decades towards the basses, the shads, and the white perch and other warm water fishes. The changing species means that water clarity will probably decline again because gobies are causing declines in the mussels. We can discuss whether that's a good thing or not. The spiny water flea will contribute to lower abundance of some of the zooplankton species that we have in the lake that are important for fish populations, but fish also feed on the spiny water flea. So the end result of that, you'll have to wait till the fall to get the final word. The mayflies, fascinating species, coming back to what it used to be when there was really abundance around the lake. And finally, we have sturgeon in the lake right now. I predict that we'll have a 200-pound sturgeon present in the lake in the next couple of decades. And give me the next slide, just to show you what a 160-pound sturgeon looks like. This one was caught in Oneida Lake and released again. It was a female caught by Tom and Tony here a year ago. So 160 pounds, 200 pounds is not unheard of for this species. and I hope you get to see them sometime. And I'll leave it at that. I could have talked for hours, perhaps, on Oneida Lake, but Aaron only gave me 10 minutes. So thanks for listening to me.
Fantastic, Lars. Thank you so much. Yeah, next time maybe we could do more presentation. You can give an update on maybe the lake has changed considerably, because that'll be fall of this year. But thank you very much. That's very, very helpful to give us some baseline data on the lake itself. So thank you again. Okay, so now before we get into the question and answer piece, I've alluded now to the watershed model a couple of times and the lake model, and Lars just mentioned it as well. The 9-element process is a little bit special and a little bit different from other planning processes because it does have these models. So I'm going to just kind of run through them very briefly, just to give you an idea. Again, these are very intricate digital models, and we could talk about them extensively, but we're going to try to keep it light for now, and then next time maybe we'll have a lot more to talk about. So just to say, all that's to say, the models are going to help us quantify existing conditions and what we think or hope the future could look like. So they're used to simplify and represent large, complex systems, and we can use them to get a handle on, again, a quantitative basis for making recommendations. All right, so you can think about the watershed model as really having 4 broad categories of inputs. There's the weather and the geology. And then there's the human influence, things like the land cover and how the land is managed. So that would be things like zoning regulations related to pollutants, or forestry management, or your subdivision regulations, everything, all the rules related to how a watershed is managed, how the land is actually managed. And the watershed model takes a lot more inputs than this, but really these are the 4 broad categories, and it generates, what's the pollutant loading to the lake? And then, that's sort of calibrated using existing data. What does the actual data about, the water coming in from tributaries tell us about the quality of the water coming into the lake? And you use that to calibrate the watershed model so that you have a representation of existing conditions. And then you can kind of play with those variables to see what would happen if, say, the weather were to change, if the climate's going to change, as Lars was just saying, over the next 20, 30 years, if there are changes to the land cover, or there are changes to how land is managed. And this land management here gets to that best management practices that I was mentioning earlier, that suite of tools you can use to, influence what's going on across the watershed, but then influence how what the quality of the water running into the lake is. That data then, the data from the watershed model can then go into a second model that simulates conditions in the lake itself. So again, this is there's so much more to it than just what you're seeing here, but this is really just the Cliff Notes version. The Oneida Lake model is going to take in a lot of inputs. It's going to look at how the layers of water mix, the lake's temperature, the climate, the east-west and north-south orientation of the lake, and how that's affected by wind patterns, the aquatic invasive species. All of these factors are then going to go into the lake model, and that's going to kind of give us a picture of the water quality. And just like the watershed model, it's calibrated to existing conditions, and then we can see if there are changes in the watershed that we're going to model. How does the water quality change as a result of that? So that's the basic, very, very basic in a nutshell version of the 2 models, the watershed model and the lake model. So how do we use them? Well, so, it's kind of like it's this question again of how would climate change and other changes affect the lake? And then what can we do about those changes that are coming, say climate change? What can we do about that at the watershed scale? So if the lake is going to be warming, we might have a greater sensitivity to pollutants, and we may have to control those pollutants. We may have to regulate those or do more than we're currently doing just to maintain the current lake quality. So we can simulate that in the models and see how the lake would hypothetically respond. That gives us the basis for that implementation plan that we talked about earlier, those steps 4, 5, and 6, the 9 elements. And then we go back to our long-term monitoring and we ask, did it all work? So again, in a very, very small nutshell, that is the explanation of the watershed model and the lake model. And that's really the basis for the whole 9-element plan. The 9-element approach, as I say, relies on kind of using the modeling and developing this quantifiable framework for pollutants. But all of that is not to say that other issues and other concerns are left out. As I said earlier, the process is flexible enough to talk about all of that. So as we move into the next part of the meeting, the next part of the meeting is questions and comments. But also after that, we're going to be getting into kind of this interactive thing to talk about, issues with the watershed. And so, whatever concerns you have, things that may not have anything to do with all the modeling things I just talked about, feel free to bring those to the table. All right. So now it's time for your questions and comments. So please, you could use the raise hand reaction, which is on your little toolbar right about there. If you have a question, or you can put it in the chat. If you have any questions on any of the material or just any comments about Oneida Lake in general. I am not seeing any questions. Does anybody have any questions? You can raise your hand, or you can just unmute yourself and ask a question. Oh, Ed, it looks like you're asking a question, but can you unmute yourself? Ed Mills, are you trying to ask a question?
How's that?
Oh, that's good.
Yeah, I have one comment, and that is one of the things that the United Lake Association is concerned about, or a couple things actually, is the impact that the fishery has on the economics and social aspects of the watershed, and that's certainly a prime area to be focused, I think, in terms of the modeling effort. The other is the sedimentation issue. It's been going on for some time. The input of sediment in these major streams in the southern part of the watershed. We're losing habitat. Those areas are becoming more shallow. They might be more conducive to having invasive plants like butter chestnuts and so forth and so on. So those two elements. One thing I also have a concern about is, from my own perspective, is the emerald ash borer. We've lost a lot of ash trees. Is the climate change and invasive species change perhaps? How is that going to affect the debris coming into the lake and the issues of safety and all those kinds of things that we have to think about, not only now, but in the future? Are we going to have more invasive forestry pests that'll change the landscape? I'm not sure those will be included in the modeling effort, but certainly those kinds of things are going on and they're going to affect the lake for sure.
Yeah, that's a really good point. I in all the conversations that we've had so far, I don't think anybody's really brought up that emerald ash borer as a concern. I know in other watersheds, in the Finger Lakes, there's a similar concern with hemlock woolly adelgid, the invasive. It's not an aquatic invasive species, but theoretically, is altering these watersheds by damaging the trees that are holding together the soils that, help make up the watershed.
If you look at the watershed, particularly in the flatlands in proximity of the lake, you see huge patches of dead trees now. And so that's going to have some ramification, like you say, on soil loss, on debris that's going to flush down into the lake. So anyways, I guess one of my points is we need to be open-minded on this modeling effort and look at the real broad picture here. Not only what's in the lake, but it's what's in the watershed.
Yeah, yes, exactly. I completely agree. I think, there are some things that the model can capture. There are some things the model can't capture, but that, regardless of whether or not it's in the model, it will certainly be something that the plan talks about and a recommendation for, ways to keep the watershed together, ways to make sure the water quality is maintained. So the recommendations and the plan discussion itself can completely and will address these very questions. So yeah, I mean that's the kind of input we're looking for completely is what are the concerns across the watershed.
Well, I have one other comment. We want to keep our CO2 in the soil, and any effort that we, as part of the scenarios, I guess, part of the modeling is what if we encourage planting, for example, after crops have been harvested in the summer and fall, planting rye or something green through the winter months to prevent soil erosion and spring runoff and heavy rain events. That certainly I would like to see as part of the scenario aspect of the modeling.
Yeah, absolutely, and that will almost certainly be something that's a best management practice scenario that we talk about. That's been used in other 9-element plans in the state. So that idea of using cover crops to reduce soil erosion in the winter is very effective. For one thing, it certainly helps reduce sediment and phosphorus loading to the lake, and it can be plugged into that watershed model. So that's one that's got a real strong. It's a real strong candidate, kind of right out the gate, if you will, for inclusion as a scenario. The cover crops, and increasingly, you're hearing about that being kind of tied to corporate. Corporations have an interest in funding that because they can then use it as carbon credits. I don't know the mechanics of that at all, but I think that's got some interesting potential to see if those efforts can work hand in hand, protect the watershed and get carbon reduction credits, carbon offsets. Okay, we had another question here. Was there any explanation for the extreme algae growth 2 summers ago? The bays were completely choked out. Lars, do you know anything about that? Or I'm not sure who else is on from the team.
Well, I'd be happy to talk about it. So the algae growth seemed to vary a lot between years. And this year, we did not have a lot of algae growth. But the year before, and then a couple of years before that, we had a strong high year as well. I think it's related to the rains and the phosphorus input through the streams. But I'm going to look more at that associated with this modeling exercise that we're doing. So it's a great question. We tried to understand this for quite a while, and it's more difficult than I expected.
Interesting.
So there's another hypothesis out there that if you had quagga mosses coming in, more filter feeding on the algae that competes with the blue-greens that are causing these blooms, that would increase the blue-greens. But we're not sure about that. At least I am not. Other people would argue that is the case. Overall, though, although we did have a year ago Not in 2022, but 2021, I think it was really high blue greens, although I have to check. Overall, we don't have more blue greens in Oneida than in previous decades, which is in contrast to some of the like Skinny Atlas Lake and Owasco Lake.
Yeah, that's surprising.
Why do you think it's surprising?
Well, because my understanding was, you're saying the lake has been warming, and so I thought with a warmer lake, say everything else being equal, a warmer lake you'd get more cyanobacteria.
Fair enough. That's also another hypothesis why you have more blue greens in these other lakes. But we have seen an overall decline in phosphorus levels in the lake if you go back to the 50s and 60s. So where they were maybe 2 or 3 times higher than what they are now. So that probably has, one thing causes more blue greens, one causes less.
Yeah. Let's see. What pollutants what pollutants will be modeled, quantified by the 9-element plan? Great question, Emily. So what we have, I was kind of alluding to this process of calibration. To calibrate the watershed model and the lake model to existing conditions, we need data on existing conditions. So, you can't just kind of create a model and sort of expect it to work just because you have all the inputs correct. You need to calibrate it to how things actually are and sort of play with the variables until the model produces results that are similar to, the way things actually are. Kind of a long way around of saying that. So the data that we have is set up really for phosphorus. So we are anticipating that the pollutant that will be modeled will be total phosphorus in the water. Now, as Ed was saying, sediment is also a major concern with this lake. We're not really set up to model sediment per se. However, as we go along, the things that affect phosphorus loading affect sediment loading. Those two kind of go hand in hand. A lot of the phosphorus that comes into the lake is attached to sediment particles. The runoff from agricultural fields is, it's carrying phosphorus, it's also carrying sediment. So when we talk about things like, say, cover crops, or you talk about planting vegetation along tributaries, riparian buffers to prevent runoff from running directly from an agricultural field into a tributary. Part of the idea, which you can really measure, what we're going to measure and model will be phosphorus, but that will also, address this sediment question. So the short answer to your question is we really only have the tools to talk about phosphorus per se, but that doesn't mean that other things won't be addressed in the model. I hope that answers that question. Okay, now here's a question. Is there an issue with sewage? Lars, do you want to handle that? Is there an issue with sewage? I mean, I know there are multiple wastewater treatment plants in the watershed, but would you say that there is an issue per se with sewage?
Yeah. Well, all right. So we have the highest concentration of phosphorus going out of Oneida Creek. And that associated with that, Oneida has a sewage treatment plant. And I think we just looked at some data from their preliminary that's the one stream where phosphorus, how should I say this? Phosphorus is high, but it's declined when you have a flood event, which suggests that it's diluting the phosphorus that comes from the sewage treatment plant. So this is, yes, we do have problems. I think they are scheduled to improve that sewage treatment plant. We also have phosphorus coming in from groundwater, which we are studying. That seem to increase in areas with septic tanks, but we don't have many of those left around the lake, so should be better.
Yeah. Okay.
I guess I would just add on as far as the sewage treatment plants. I mean, the Oneida plant, it has a permit, and they're meeting their permit. The plant is being upgraded, but I wouldn't call it a problem with a sewage plant. So there are sewage plants all around the lake, but they do have permits and they're monitored and they submit monthly reports and so forth. So, most of them are in quite good shape. So I wouldn't call it a problem, but always something to, be aware of.
Cool. Thank you, Matt. Oh, okay. Another question here. Is there a population of Eurasian milfoil in the lake? And if so, does it seem to be growing? And is there any way to control it? I'm going to defer to you again on this one, Mars. I'm pretty sure there is.
Okay, there's plenty of Eurasian milfoil in the lake. They are now part of the plants that we do have. It's not necessarily the most common plant, certainly not lake-wide, but in some areas it's common. We have native milfoils as well, and we have some new species of stargrass, I think it's called. Lopsis is the Latin name. That has, if you are on the lake and you see this mat of plants in some areas that you didn't recognize as common before, it's probably that one. So it's changing. Milfoil is part of the system, I guess.
Okay. Okay. What models will be used? For example, SWOT primarily focuses on agriculture. The watershed model is called the Generalized Watershed Loading Function, GWLF. So we're not using the SWOT model on this. This is a little bit different. I don't think we have, I don't believe our watershed modeler is on the call tonight. Yeah, so that is the model. Generalized Watershed Loading Function is what it's called. And the idea in this case, I should have said this in the presentation. I don't know why I didn't. This is an interesting piece of information about the watershed model. The idea is to split the watershed into two pieces in the modeling. So the southern half essentially is distinctly different. The southern half is much more agricultural. The northern half is much more forested and less developed. So the watershed model is going to kind of treat those two separately, obviously as part of an interconnected system, but the inputs are going to be different to kind of account for that shift in those two parts of the watershed. So to me, that's really kind of a great aspect of this. That's something I'm excited about, getting that nuance in there. Will the model be including all the sewage treatment plants? I believe so. I believe that is a big input to the watershed model. Although, to be honest with you, I'm not entirely sure about that. I know that obviously the watershed model and the lake model, utilize data from tributary monitoring. So in that sense, whatever's coming in through the tributaries, whatever's coming in through Oneida Creek, the extent that the water's, the sewage treatment plant is affecting that's how that gets incorporated. But yeah, I believe the watershed model takes those sewage treatment plants into consideration. All right. Does anybody have anything else? Any other questions? Very good. Thank you all very much. Those are great questions. Good discussion. Okay. Now, I'm going to ask Lauren to put a link to what we call the Jamboard into the chat. You should be able to just click on that link and open up in a separate internet browser window this thing called the Google Jamboard. This is going to be how we get your feedback on a vision statement and some goals, and then any other issues you want to talk about, make sure they're documented. Normally for an in-person public meeting, we would have, boards and sticky notes, and you'd write down your issues with a magic marker. Obviously, we don't have that, but this online tool gives us that flexibility to be able to kind of grab that stuff from you guys. we definitely are interested in whatever you've got, any kind of input you have. The draft vision statement we have currently is kind of adapted from the 2004 management strategy that I alluded to earlier. That draft vision statement is this: watershed stakeholders will work toward the protection and restoration of a multiple use lake and watershed that sustain healthy land, ground and surface water, fisheries, aesthetic values, cultural resources, economic vitality, wildlife habitat, and water-based recreation. So that's one of the things we're asking for input on. If you feel like we left something out, or you think it should be rephrased, or you just think you got a whole different vision, please provide that in the Jamboard. Also, some examples of goals. We're looking for your goals. What are your ideas? What do you think we need to make sure this plan, as we go forward, what does it need to include? So going back again to the 2004 management strategy, some of the ideas that we're focused on for that were reducing soil erosion and sedimentation, managing flooding, preventing septic runoff, controlling and preventing invasive species, strengthening the fish community. Things that really make sense that still resonate 20 years later. Other examples: invest in agricultural BMPs, promote land use and development controls that improve water quality, implement stormwater control measures. So obviously these are just examples. We're very interested in your ideas. So as you're looking, hopefully you're opening up the Jamboard. Let me know if you're having problems with that. But the controls are pretty intuitive. There are 3 pages, and you can flip between the different pages using the navigation buttons at the very top of the page. You can use the annotation tools that should show up on the left-hand side of your screen to provide your comments. There's a sticky note tool. There's a text box tool. You can use, I think, a pen. You also have the ability to erase other people's comments, but please don't do that. It's no big deal if you do. We can get them all back. But that's the end of the formal presentation. I don't have anything else really of any substance to say. If you have questions, you can email them to me at oneida9e@cnyrpdb.org. You can keep watching the progress of this project at www.cnyrpdb.org/Oneida Lake. That's where, in the events section, that's where tonight's video is going to be posted in a couple of days. One more comment. Oh yeah, that's right. And Lauren just put that link in the chat. And we also have one more comment about the sewage pollution right to know law requires notification of sewage discharges and can be accessed online there at that link. Thank you very much, Emily. So that gives us a little more background on that sewage thing. All right, if there's nothing else, I'm actually going to go ahead and end this Zoom meeting. The Jamboard is going to stay up. Does anybody else have any final thoughts or questions? All right. Okay. Well, I'm going to officially end the Zoom thing, but the Jamboard, as I say, is going to stay up. Thank you all so much for your time. I know this was kind of a lot all at once. So thank you very much for bearing with. And we're going to keep this process going. And we'll hopefully be back in the fall. All right. Thanks again and good night.